Okay, first of all, I think that's big enough. That's the repo for this talk. And the other reason I'm giving this repo out right now is because, let me find my, not that. Would my thing go there? So there is a Binder link that is not working because Binder crashed this morning, and so it didn't actually make my Docker image. It only just came back on like 10 minutes ago. I was getting gateway not found for most of the morning. The Colab link does work. It won't show you the slides, but it'll give you the notebook, so you can follow along. So if you go there and you click on the Colab link, there is actually there is a live notebook on the Google Colab. Oh, sure. So WebFeed is my username and PyData Miami in camel case. Okay. Does it actually feel? I'm still thinking. Okay. Okay. So on that note, let's get started. So I'm going to start. So this is a really big crowd. I wasn't expecting, wall-to-wall audience here. So this is going to be interesting for me to put my head on a pivot. I'm much more used to teaching long rooms than wide rooms. Really quick show of hands. Since we're at PyData, how many of you are more than novices, so intermediate or higher in Python, not PyData, but Python? How many of you are beginners? How many of you started this week with Python? Yeah, there's going to be a few, trust me. So let's see here. 3 months of Python? More than 3 months? Less than 3 months? Okay, more than 3 months. Okay, so the other group is the one I'm worried about. Less than 3 months. So not too many, so you'll follow along. I won't make it too crazy. Because I have to make certain assumptions because it is 90 minutes and compressed. So first of all, quick introduction. My name is Abhijit. I flew down here from DC. I have my own, I'm a consultant data science consultant in DC. And I also do a lot of teaching through District Data Labs, who has a booth down this hall. And I saw Tony hanging out in the back somewhere, who's the head of District Data Labs. We do a lot of training in data science using Python and R. So today I'll be talking about sort of one package mainly. It's called Pandas, which has nothing to do with the cute furry animal. It has everything to do with, it's Python for data analysis. The founder, the benevolent dictator for life for Pandas, will be here tomorrow giving a keynote, Wes McKinney. So someone was like scaring me that he's going to be in here today, so I'm safe. So Pandas actually changed the game in terms of statistical analysis in Python. So before that, just a little bit of context and history, there were packages called NumPy and SciPy and Matplotlib, which were done in the 90s. And were very popular, but they were primarily meant to be a replacement for MATLAB, for those of you who still use MATLAB for numerical analysis. So what's wrong with that? MATLAB is a perfectly good prototype to clone on. Well, the issue is that MATLAB assumed that you are dealing only with numerical data because you're only an engineer. And so in reality, as people came to realize, data is heterogeneous. So you can have text data and numeric data and indicator data in the same in the same Excel spreadsheet, if you will, in the same table. And now we've gone even further, say you can have images in the same data, you can have web pages in the same data, so on. So it's very heterogeneous. But we're not going to deal with those kinds of sort of bigger data clumps. What Pandas did is it created structures to allow heterogeneous data to stay together, which is really, really useful when you're thinking about data analysis, because it brought you back to what you're familiar with in Excel, in terms of a rectangular sheet of data that stays together. If any of you have ever tried importing heterogeneous data in MATLAB, ergo in NumPy, So we can see if that's actually a splitter.
Find out right now.
We'll find out. It created two separate data objects, one for the numeric stuff, one for the non-numeric stuff. And now you have a problem because you can't easily match them, right? Because now one is like all the numeric data, but then everything else is missing where it's text, and vice versa. So we're going to go through some of this. Let's slowly get going. So the tools that I'm using today are based on the Anaconda Python distribution. If you're not using the Anaconda Python distribution for doing data work, what's wrong with you, frankly? There are competitors. I mean, Nthought has a perfectly good distribution, and you can download Python, pure Python from python.org. And if you have a Mac, you already have Python on it, so why am I using Anaconda? Anaconda was set up as a bundle meant for data science. It got all the right packages together. And it's easy to install, it's easy to upgrade, and it runs on all the three major OSs. So it makes life very, very easy. And it's well maintained. No, it's not a splitter. I didn't think it was a splitter, so. So the two main packages I'll be dealing with today are Pandas, which I've already mentioned in the title. And I'm using a particular version because there's been certain changes over time. And I'm also using Seaborn. Seaborn is a data visualization library. And when we get to that towards the end of the talk, I'll talk a little bit more about it. I will still be using NumPy in this talk because NumPy is the base layer on which all scientific computation is built in Python, and Pandas is on top of that. Okay, so you still need to go down to NumPy at some point. SciPy is another package that I realized I'm actually not using because I took a section away. So NumPy, the bottom three here, NumPy, SciPy, and Matplotlib, were the original PyData stack. And then we got Pandas, and then we got stats models, which is the modeling side of things, scikit-learn, which is the machine learning side of things. There's other scikits, scikit-image, which is the image analysis, NLTK, which is the natural language processing, and they're all sort of together now. And so you realize, if you go down to the end of the hall, to that table with all the stickers, and realizing almost all those stickers are for data analysis packages in different contexts, you realize how much this has grown in the last 10 years. We're talking about the baby steps in getting into that today. So I've got a few objectives, and we'll see whether we get through them. I'm going to concentrate on Pandas because I think that's what's more important. Pandas is really a tool for data ingestion and data munging. What does that mean? You have data stored in some way, shape, or form that you got from an experiment, from a colleague, from scraping the web, from whatever. And you need to bring that into Python. That's one of the big roles that Pandas has. And munging means transforming this data in different ways. And we'll talk about different ways of transformation to make the data useful for analysis. Raw data is almost never useful for analysis. You actually have to transform it into a way that other functions can actually work on it. So you want to go from a raw data set to an analytic data set, and Pandas is the big toolbox to do that. So we'll talk a little bit about data cleaning, mainly about missing values, transforming data sets, as I said. We'll talk about the split apply combine paradigm, or the group by paradigm, or map reduce, however you want to think about that particular paradigm, is the same thing. And then doing data summaries. So Pandas is really not about modeling at all. It's about getting data to a state where you can model on it. Okay. The next objective is to look at some plotting. So Matplotlib is the old granddaddy. If any of you have used MATLAB, you'll be very comfortable doing Matplotlib because it's almost the same syntax. Unfortunately, what that means is that it makes certain kinds of plots very, very verbose to write. And so Seaborn is one of many visualization packages out there right now. But Seaborn is specifically created for statistical data representations and make certain things very, very easy. It's still, so just as Pandas is sitting on top of NumPy, Seaborn is sitting on top of Matplotlib. So you can go down if you want, but the top layer is often the easier way to go. And we'll go through different kinds of graphs that we can play around with. And if we have time, we'll talk a little bit about statistical modeling. I don't think we'll have that much time, but we'll see how it goes. Okay, so when starting up, this is part of my first question. I assume you know the basics of Python. So you know how to turn on a Python interpreter, you know how to turn on a notebook, you know how to write basic things. I'm going to review two particular structures that are actually very useful, both in data analysis as well as in talking to pandas in some sense. And they're lists and dictionaries, or dicts. And I always make the distinction that lists are square brackets and dicts are curly braces. There's also one more that I'm not going to talk about, which is tuples, which are the round parentheses. And everyone gets confused when you start off with Python as to what's what. So we're only going to talk about the squares and the curlies today. So lists are a very simple concept. They're a bucket. They will carry anything and however many of them you like with you. So it's literally a bucket. The members of a list can be of any kind of object. So it could be a number, it could be another list, it could be another dictionary, it could be a text, a sequence of text. It could be whatever you like. So lists are completely heterogeneous in terms of their content, but they are ordered in that there is a sense of what's the first element, what's the second element, what's the third element, and that's important to think about. So there is a beginning and an end to a list. So for example, this is a very simple list. I'm probably going to have to blow this up a little because I just realized this is quite small. Oh, sorry. Okay. What am I doing? Is that better in the back? I know we're not very deep, but I know in the corners probably going to still have to squint because that's a ways. Or maybe one more up. Okay. So this is a very simple kind of a list where I have a string, another string, a number, and a boolean. A boolean is a yes, no, it's a true-false variable. It's a special kind of variable. If you're not very familiar with Python, one of the things you will realize very quickly with programming, most programming is case sensitive. So true has to have a capital T in it, and small r, small u, small e. Same with false. So these are just two lists which have the same structure essentially. And so there's a sense of what the first element is. So from L1, the first element is my first name. Now one thing you'll notice right now is I said it's the 0th element. So Python starts counting at 0. If any of you have done R or have done, God forbid, Fortran, way back when, those start with 1. C starts with 0. Python starts with 0. I think Java starts with 0 as well. So this is a 0-base index. Similarly, you can grab parts in the middle, which is called slicing. So you can say 1:3. So look, it appears as if this would give me 3 elements, but it only gives me 2. So one of the semantics in Python that's important is that when you see this colon notation, so 1:3, it means it takes the first one, but it does not take the last one. So 1:3 really means 1 and 2. So it's up to 3. So this only gives me the second one, which is Bergman, and the third element, which is the number 43. So this is something that's important to remember for 90% of the time. There's a big aberrant case inside pandas where that convention does not hold. And it does the natural thing of actually taking both ends. So as I scroll. So A colon B means you include A but stop before B. So if it was 2 colon 6, that really means it's 2, 3, 4, and 5. No 6. So if you want to start from the beginning, you can just do colon 3, which would be 0, 1, and 2. Okay? The nice thing in Python is you can also start counting from the right. In that you can write L2 minus 2. Okay? The last element is also minus 1. So the rightmost element is minus 1, and so minus 2 is 1 to the left of that. So that's why it comes to 43, which is this false would have been the minus 1th element, this is the minus 2nd element, that would be the minus 3rd element. So you can go either way, and you can slice either way. And you can also replace elements in a list. So you can just say this element here I'm going to now change to 49. And so if you print it out, it actually changes the original list. So lists are mutable in that even once you've created it, it's not set in stone. You can keep changing elements of it. You can add to it, you can subtract from it, you can change it. You can do all sorts of. Lists are probably the most flexible object in Python. Dictionaries are the other really nice structure that I use a lot. And they're essentially key-value pairs. You have a key and you have a value. There's some restrictions on what can be a key. A key can be a string, so it can be literally a word, in quotes. It can be a number, or it can be what are called tuples. So tuples are the third kind of thing I talked about, which is the round braces. Think of tuple as a fixed list. Once you've created it, you can't change it. It's set in stone. I'm not going to use tuples at all, so I'm not going to worry about it today. Values, just as lists, can be anything. It could be another list, it could be another dictionary, it could be whatever. The other important thing is there is no ordering, right? And so this is a very similar dictionary, very similar to the list I made. But now you notice there's pairs. So first gets a value, last gets a value. So the key is first, the value is Abhijit. The key is first, the value is Tracy, and so on and so forth. So I can call elements by key. So if I did D1 and I gave it the key, it gives me the value. Note, if I change this to say, okay, it's the first thing, so I'm going to do D0, D1, 0. I try and run that, it gives me an error saying, oh, I didn't run this first, that's why. So that's the wrong error. So it says key error 0. So it can't find 0 among the keys. So there's no sense of a first element or a second element or a third element. However, just to make it just that much more confusing, you can have keys to be 0, 1, and 2, and so on. So you could have a D1, 0 if one of the keys was 0. So for example, if I change that to 0, which is valid, and then that gives me a value. So just to make things just a little bit more confusing.
So there's only like one way to call the index?
Yeah. No, actually that's probably not true. So let's try this, because I think this is true. No, that does not work. Okay. So it doesn't have an attribute. So you can do this so this is the only way to call a dictionary value. Keep it something that actually works. So Python has a core group of functions, which is the core Python. But it's been expanded using packages, as is almost every sensible programming language in the world. Most of the packages, so traditionally you used to load packages using a command called pip, and you'd get it from a repository called PyPy. Anaconda uses a different system, which is called Conda, which in many ways is more comfortable to use, I guess. And they have their own repository, but it's essentially equivalent in many ways. So the package that I'm installing here today, if you use the Anaconda distribution, will already install, so you didn't have to do a conda install anything. And so the typical command is import the package. But you can import the package as something else. You can alias it. Why? Because we're all lazy typers. This is fine until you start getting into beautiful soup and SQL alchemy and really don't want to write that over and over again. Or matplotlib.pyplot. Gets old fast, right? And so you alias it. And these are the standard aliases in the field. So NumPy is almost always NP, Pandas is PD, Seaborn is SNS. Don't ask me how these came about, but they came about, and that's what everyone uses. And so what's the package? A package is basically a group of functions. They're modules, technically, if you want to look at the nomenclature. But they're essentially groups of functions that are put together that you can access from the package for particular purposes. And the way you grab them is you do package.function. If there's submodules, it would be package.module.function. We'll see a couple of those as well. But basically, there's a dot notation. So when you're naming your variables in a program as a programming language, don't use dot. Dot is protected, right? We forget this sometimes. We think that that's easy. So the convention is typically camel case or pothole case. Pothole case is if you join words by underscores, and camel case is capital wherever. So, for example, I'm taking this list L1 that I created a few slides ago, and I'm making it into a NumPy array. So NP is my alias for NumPy. Within that, there is a function array, which transforms this list into this array, which is essentially has the same content, but it has some more structure to it. One of the things that you will notice in this array that's written in out51 is that the number 47 and the boolean true are now quoted. Remember when I started this, I said that MATLAB had this problem that it needed homogeneous data sets. Numbers stay with numbers and non-numbers stay with non-numbers. Well, what happened here is that it's seeing there's two things that are non-numbers, so it'll make everything non-numbers, everything a string. And so we just lost information by doing this, right? Because now suddenly you've got, a string where it should be a number and a string where it should be a yes/no. So that was one of the problems with sort of heterogeneous data and NumPy. And this is true throughout NumPy. All NumPy arrays are homogeneous. So be they one-dimensional, two-dimensional, however. Which can be great, because if you're just using numerical data, you can do a lot of stuff very fast with NumPy. If you're dealing in the real world with heterogeneous data or metadata or stuff like that, it's a pain in the ass. Oh, got it there. Oh, by the way, one of the things you're realizing because I'm realizing as I'm typing, my cells are actually live. So I'm using a Python package called Rise, R-I-S-E, which takes a notebook and transforms it into slides, but it keeps the live notebook underneath so I can type and run stuff. So it's very cool. And actually, if you actually download my GitHub and install Rise on your own computer, you can get the same effect. Okay, so on to pandas, which there's a reason I chose this particular picture of a panda, because pandas is meant to make things easier so we can have more time to laze around. I was just reading an interview that Wes McKinney gave in 2017, where he's saying that the biggest reason for doing pandas is to make things easier for people. So you can write 2 lines of code instead of 25. So you want to become a lazy panda. Of course, your boss will say, well, since you're so efficient, now you can do 10 times the work. It's like, no. But nonetheless. So it builds off of NumPy. So I just showed you a one-dimensional array. That, in pandas, becomes a series. The series still needs to be homogeneous, but it actually has some other metadata with it that makes it interesting. And a 2-dimensional NumPy array, which traditionally would be called a matrix, is in pandas called a data frame. The name data frame is not accidental. It mimics R's data frame object, which is the first one that actually allowed heterogeneous rectangular data sets. And the data frame object is really what transformed Python into a data analytic language, in my opinion. It was a scientific computing environment before with NumPy. It is now a data analytic environment, which is broader, in my opinion. So I can just take that list and make it a series. This stays homogeneous, but what adds to it is you get these 0, 1, 2, and 3, which are literally labels. They're like row names. So you can actually change the 0, 1, 2, 3 to A, B, C, D, whatever you like that makes sense. So the series object starts putting metadata onto your original data in the form of, in what in Pandas is called index. You can think of it as row names or names or whatever. So it's a label. And this can be useful. I mean, the series, so Pandas historically was used for time series data because Wes McKinney used to work on Wall Street and he was interested in the stock ticker. And so the labels used to be the dates. And you were talking about series of stocks, right? And so you could literally pull off a date just by its label, the data from a date for its label. Data frame is a bit different, and I think it's the biggest game changer that's why we have PyData conferences. It's a data frame you have to think about as a collection of columns. So if you think of a data frame like an Excel sheet, if that makes it easier for you to think about. But the structure is columnar. So you think of each column as a separate entity, and you've bunched these columns together. So each column is a series. So this is a bunch of series, which means each column has to be of the same type. But different columns can be of different types. So you literally have the phone directory in a data frame, right? You're going to have the name, street name, city, state, zip, which is a number. But you should not keep as a number because anyone here from the Northeast, from Boston, you have a 0 in the front, so that's always a problem. And then you can add a telephone number to it or however. So it's a heterogeneous database that you can put into one rectangular sheet. And so one of the ways you can create a data frame, I created these two dictionaries. I put them together since they have the same names, so the keys are the same. Those keys become the column names. So I had age, first, last, and male. It ends up being arranged alphabetically. As you notice, you can change that later. The formatting is a function of the notebook. It's not what you would see on a console, right? And it also gives you the row labels. So these are still the index of the data frame, and these are the columns of the data frame. Let's see if I actually ran that. Name PD not defined. Okay. I'm going to go back for just one sec because I need to. Oops. Okay. Go there. I'm just going back to where I loaded the packages. There we go. Let's make sure that runs. There we go. So this is one of the problems with running a notebook. And if any of you follow Joel Gruss on the interwebs, Joel wrote a really nice book called Data Science from the Command Line. But he's been very loud in the last 2 years about saying notebooks are not the way to go. And this is the reason. If you went through and didn't do certain cells, there's dependencies. And if you do things in different orders, you'll get different results. So it can be awkward.
So can you change it to just pandas.dataframe?
Pardon?
Can you just change it to like df?
No, but I still have to import pandas.
Okay.
The import hadn't
So
happened.
the scope is only in this line of the code?
The scope is in the entire thing, but if I didn't run it before,
Okay.
I just showed it to you, right? I didn't actually run it.
Okay.
So I went back to run it, and now if I run this, it works. Because I also ran the cell that had D1 and D2 in it.
Got it.
But I've been skipping over stuff. I'm not running everything. And so it's like, oh, you didn't run, so I don't know what that was. Because you write linearly, right? So let's see what I was going to do there. Okay. So there's a couple of things you can do here. So df dot, actually I'm going to start a new. Columns. So the columns, it extracts out the
Keys.
column headers, which were the keys, and index grabs out the row names. So in this case, it's just 0 and 1. So it's saying there's a special object called a range index. It starts at 0, end at 2 by 1s. But you can look at the types here. So if I did df info, it tells me a bunch of things. So the index is a range index, 0 to 1. The columns, there's a column called last, column called age, a column called male, and a column called first. The 0 is with the index. So pandas and NumPy are NumPy is actually sort of weird because the object, the types here that you're seeing in object and int64 and all of this, those are actually coming from NumPy because it's based on NumPy. In NumPy, there's no good string object, and so all the string objects are called object. Age, of course, is an integer, and male is a boolean. It's just a true/false. So whenever you see a type object in pandas, just assume that it's a character variable, because that's the surrogate they're using. So there's different ways of creating data frames, and like I said, this is going to be we have a very short time period. The pandas documentation is actually fantastic, so if you have questions about anything here, you can certainly reach out to me, but you can also go to the pandas documentation. It's actually quite good. You can create a data frame from a NumPy array or from a single dictionary where you have arrays. Now the crucial thing here, so what's the geometric nature of a data frame? It's a rectangle, right? Which means every element, every column has to be of the same length. So if I created a dictionary that first has 3 elements, last has 3 elements, and age had 2 elements, it would not be a data frame, right? Because they're not all the same length. So you have to ensure of that. In this case, one of the things I did, sort of foreshadowing, is since John Lennon is actually dead, I put his age as a missing value, which is an object in NumPy called nan, for not a number. And so it shows up in my database as nan. And we'll talk about missing values as we go forward, but I intentionally brought it up here to expose you to it. So I put this in, but typically what will happen is you get a data set. Data sets are never complete. If you have a complete data set, it probably came from a book. I mean, seriously. So you'll see missing values often in the wild. And so just getting to show you one. So pandas, I'm going to make this a little smaller because otherwise this won't show. So if you think of this picture as sort of the entire pipeline of data analysis, right? You start with grabbing data, transforming it, doing some analysis, doing some modeling, and then reporting, and then repeat, right, as you get new data. Pandas lives in these first 2 parts. It's before the function, the algorithms and the modeling and the like. This is just to get your data ready. And so let's start off with that first piece, which is data ingestion. What does that mean? It means you've got your data from somewhere. You have to pull it into Python. So Pandas has a bunch of functions that can read data from most kinds of data sets that you will actually ever get. They're essentially wrappers around other things, but that doesn't matter. What's important and what makes Pandas really nice to use is that they use the same kind of language. So to read anything, it's pd dot read underscore something. That's the general format for it, right? So pd for pandas. So pandas is a package. Within that, there is a read underscore something that will read a certain kind of file. So you can imagine for CSV files, comma separated values, there's a read underscore CSV. For Excel, there is a read underscore Excel.